Welcome to my Ultimate Redux course. I'm Mosh, and I'm going to be your instructor over the next few hours. In this course, you will learn everything you need to know to build real, complex applications with Redux. We're not going to work on a dummy to-do app. We're going to work on a real bug tracking application with a Node backend. We'll go over functional programming principles, writing clean code, designing complex stores, middleware, calling APIs, testing, and integrating with React. I'm assuming in this course, you know nothing about Redux and want to learn everything from scratch. I will explain every line of code I write so you learn and understand all the underlying principles. I promise you, by the end of this course, you will know and understand Redux inside out. Now, before we get started, I want to tell you that I have a coding school at codewithmosh.com where you can find plenty of courses on web and mobile development. So if you want to learn more from me, be sure to check out my coding school. Now, let's jump in and get started. So what is Redux all about? Well, Redux is a state management library for JavaScript applications. We can use it with React, Angular, Vue, or even vanilla JavaScript because Redux is just a state management library. It doesn't care what library we use to build user interfaces. But why do we need a state management library to start with? Well, if you have ever built an application with a complex UI, you have probably come across this situation where you need to keep different parts of the UI in sync. Let's say the user changes some data in one part of the UI, and other parts of the UI should be immediately updated to reflect the changes. In more complex scenarios, the data can also get updated as a result of network requests or background tasks. In these situations, data can flow from one part of the UI to another and change in unpredictable ways. We have to write a lot of code to keep everything in sync, and when something goes wrong, figuring out how the data changed and where it came from becomes really complex. You might even end up with an infinite loop that is hard to break. If you encountered such problems in your applications, that is a sign you need a state management library. Facebook encountered this problem in 2014 and came up with an architectural pattern called Flux. Redux is inspired by Flux, but it has grown more popular due to its simplicity and elegance. Another popular solution is MobX. With Redux, instead of scattering application state in various parts of the UI, we store all the application state inside a central repository. That is a single JavaScript object called the store. That is a single source of truth. You can think of it as some kind of a database for the front end. So with this architecture, the different pieces of the UI will no longer maintain their own state. Instead, they get what they need from the store. If we need to update the data, there is a single place we have to update. So this immediately solves the problem of synchronizing the data across different parts of the UI. But Redux's architecture also makes it easy to understand how the data changes in our applications. If something goes wrong, we can see exactly how the data changed, why, when, and where it came from. So in a nutshell, Redux centralizes our application state and makes data flow transparent and predictable. Now that you know what Redux is, let's look at some of its benefits in action. So this is a food delivery application I have built with React and Redux. On the left, we have food categories such as soups, salads, and so on. We can select a category and add items to our shopping cart. Note that as I'm adding these items, the number of items in the shopping cart gets updated immediately. So let's add a bunch of items. Let's also add an entree. Now let's go to our shopping cart. Once again, we can update the number of each item in the shopping cart. As I'm doing this, the total price for this item, for the cart, as well as the number of items in the shopping cart get updated in real time. So all the data in my application is in sync because we have a single store where we are storing our application state. Let me show you where it is. This is Redux DevTools, a powerful tool for debugging Redux applications. It's an extension to Chrome. So over here, you can see my entire application state tree in one place. So we have these entities, we have our shopping cart, we have our food categories and food items. This auth object over here represents the current user. So we have all the information about the current user and their authentication token. We also have this UI property, which includes some UI state. Now let me show you something powerful. On the left side, you can see all the actions that I have performed in this application. So you can see I've added a bunch of items to my shopping cart. Now, if I remove the first item, green lentil soup, you can see we have a new action here, item removed. If we select this action, we can see the data associated with this action. So over here, I tried to remove the product with ID 5. Now let me show you something very cool. I'm going to put this on the left side so you can see clearly. Let's jump to one of the previous actions. The UI got updated immediately. So we can go back to any of these previous actions and restore the UI in that state. This is called time travel debugging. We can also save the entire application state in a single file and reload the application from it later. How many times have you got a call from your client or your boss telling you that a feature in your application is not working? In these situations, we have to ask them, how did this happen? Tell me the exact steps that you followed. Then we have to repeat all those steps to reproduce the bug. Now, every time we change our code, our application gets reloaded and we have to follow those steps over and over. This is very time consuming. With Redux, we don't have to do this anymore. There's actually a tool called LogRocket that gives you an always-on Redux DevTools in production for every one of your users. So if a user encounters a problem, you can reload the application in the same state as the user and see what was going on. It's very powerful. Another benefit of Redux is that it allows you to cache or preserve page state. Let me show you what I mean. So over here, note that when I refresh the page, you're going to see a loading indicator for 3 seconds, indicating a slow connection. So look, refresh. Here's our loader. Now the menu appears, okay? Now, if we navigate away from this page and then come back to it, the menu is already there. We don't have to re-download it from the server because our entire application state is available on the client inside a single JavaScript object. Also, I can select a filter here, let's say soups, and sort the menu by price. Once again, if we navigate away and then come back, our menu is in its previous state. So let's quickly recap. Redux makes state changes predictable and transparent. We can easily see what exactly is going on and how the application state changes in response to every action. The second benefit of Redux is that it centralizes our application state, so all the data our application needs is stored in a single place that is accessible by all parts of the UI. With Redux, we can also easily debug our applications. We can easily cache or preserve page state and implement undo or redo features. So if your application needs these features, you may want to consider Redux. The great thing about Redux is that it works with any libraries for building UIs. You can use it with React, Angular, Ember, Vue, even vanilla JavaScript. Plus, we have a large and growing ecosystem of add-ons. So these are all the great things about Redux. But all these great things come at a cost. Redux introduces some indirection and complexity in your code. This is partly because Redux is based on functional programming principles, and a lot of developers are not familiar with these concepts. But don't worry, I'm going to teach you the basics of functional programming very soon. Another problem with Redux is that Redux code tends to be verbose. You have to write some boilerplate code to get things done. This is one of the main complaints about Redux. So in this course, first, I'm going to show you the traditional way of writing Redux code, which has a lot of boilerplate, but later on, I will show you the modern way of building Redux applications. You're going to learn how to write clean and concise Redux code free of boilerplate. So with all that, is Redux for you or not? We'll talk about that next. If you have seen any of my courses before, you've probably seen this guy. His name is John Smith. He's kind of arrogant and opinionated about everything. So he says that he uses Redux in every project, and so should you. Well, I tend to disagree. For every project or app, you need to understand what problem you're trying to solve, what your constraints are, and what solution optimally solves the problem according to those constraints. There is no such a thing as one-size-fits-all in software engineering. If you're on a tight budget, if you're building a small to medium-sized app with fairly simple UI and data flow, if the data doesn't change in your app, or if you simply fetch the data on every page load and render it statically on the page, Redux is probably not the right tool for you. It's just going to complicate things and slow you down without giving you much value. So don't use Redux or any other tools because they're popular or someone told you to. Always think about your needs and the kind of app you're building. Now, John argues that you should always use Redux right from the get-go because the state management problem will get messy sooner or later. So it's better to have the right foundation in the project. Well, that reminds me of the old proverb. If all you have is a hammer, everything looks like a nail. Developers like John are often used to a certain way of building apps. They solve every problem using the same solution. And honestly, I think that's just basic human nature. We don't want to constantly think and figure things out. We like to be on autopilot. But if you want to be a real software engineer, you need a different kind of attitude. You need to be an active problem solver. So the bottom line, Redux is great. It provides a number of benefits at the cost of extra complexity in your code base. You will see this as we go through this course. For every app, you need to think about all the pros and cons of Redux and see if it's really the right tool for you or not. In fact, Dan Abramov, the creator of Redux, once said, "You might not need Redux." This is a great blog post to read in your spare time. So, at the end of the day, I encourage you to watch this course to the end because it helps you see what Redux is all about and whether it's the right tool for your next project or not. Also, keep in mind that almost 60% of React projects are built with Redux. So if you're a React developer, chances are the next job or project you get is based on Redux. So you need to know how Redux code works and how to maintain it. And that's what you're going to learn in this course. If you look below this video, you're going to find the starter project for this course. So simply open this folder with VS Code or your favorite code editor. Now, all you have to do is to open up a terminal window, install the dependencies, and start the project using npm. So npm install. All right, all of our dependencies are installed. So now let's start the project with npm start. Now open up your browser and head over to localhost port 9000. You should see the hello world message. Now let me give you a quick overview of what we have in this project. So take a look at package.json. Here we have 3 development dependencies and they're all related to Webpack. In case you are not familiar with Webpack, it's actually a module bundler for JavaScript. So we can split our JavaScript code into multiple files and have Webpack combine them into a bundle. We also have Webpack Development Server, which is a very lightweight development web server. Now, over here, you can see the configuration for Webpack. This is pretty standard, nothing fancy here. So we're telling Webpack that the entry point to our project is this file, index.js, that is located in the source folder. Now, Webpack is going to start from here. It's going to get all of our JavaScript files and then combine them into a file called app.js, which is going to reside in this folder, dist, which is short for distributable. And here's the configuration for our development server. So we're telling Webpack to launch our application from this folder on port 9000. Pretty straightforward. Before we dive in, let me give you a quick overview of how I've structured this course so you can get the most out of it. Redux is based on functional programming principles. A lot of people find Redux confusing because they are not familiar with these functional programming concepts. So the next section is all about functional programming in JavaScript. We'll be talking about concepts such as higher order functions, composition, currying, immutability, and so on. The following section is all about the fundamentals of Redux. In this section, you will see all the building blocks of Redux in action. We'll be talking about reducers, actions, action creators, and so on. Now, Redux itself is a very simple library. So in the following section, I'm going to show you how to implement Redux from scratch yourself. This helps you gain a better understanding of this library, so it will no longer be a mystery to you. You will know exactly how everything works. Next, we'll talk about debugging Redux applications. I will show you various tools available to you and how to use them to debug your Redux applications. Now, some of the most common complaints about Redux is that it involves too much code, too much boilerplate, and that Redux code is ugly and unmaintainable. So in the following section, I will show you tons of techniques to write clean, concise, and beautiful Redux code. Then we're going to talk about designing a Redux store. We'll talk about some patterns and techniques that you need to know for building real complex applications. Then we're going to talk about middleware. This is one of the areas that a lot of people find confusing, so I'm going to make it super simple for you. Next, we're going to talk about calling APIs. I've seen a lot of bad code when it comes to calling APIs, a lot of repetition. So in this section, I'm going to show you a very cool technique for calling APIs. We'll also talk about some other concerns such as loading indicators and caching. The following section is about testing. Again, I've seen a lot of bad practices when it comes to testing. A lot of people blindly rate tests and feel proud. But you need to learn how to rate good tests, not just tests. So in this section, I will show you the proper way to test Redux code. And finally, in the last section, we'll talk about integrating Redux into your React applications. I'm going to show you both the old and the new way of connecting your components to a Redux store. So there's a lot we're going to cover, and by the end of this course, you're going to master Redux. That's my promise to you. So I'll see you in the next section. Redux is built on top of functional programming principles, which is foreign to a lot of developers. If you have tried Redux and were confused, that's probably because you didn't have a good background in functional programming. So in this section, we're going to cover the essential functional programming concepts. I highly encourage you to watch this section to the end because understanding these concepts is crucial to build Redux applications. So let's jump in and get started. So what is functional programming? Well, functional programming is one of the many programming paradigms or styles of programming. You have probably heard of object-oriented programming. That's another popular programming paradigm or style of programming. Each of these paradigms has certain rules about how you should structure your code to solve problems. Functional programming was invented in the 1950s, but it has become quite trendy over the past few years. In a nutshell, functional programming is about decomposing a problem into a bunch of small and reusable functions that take some input and return a result. They don't mutate or change data. With this structure, we can compose these functions to build more complex functions. Now, what are the benefits? Well, these small functions tend to be more concise, easier to debug, easier to test, and more scalable because we can run many function calls in parallel and take advantage of multiple cores of a CPU. So these are the reasons why functional programming has gained a lot of popularity over the past few years. Now, there are languages that are specifically designed for functional programming, such as Clojure and Haskell. JavaScript is a multi-paradigm programming language. It's not a pure functional language. So it has some caveats that you need to be aware of, but we can still apply functional programming principles in JavaScript. And that's what I'm going to show you throughout the rest of this section. All right, our first lesson here is going to be a JavaScript refresher about functions. Chances are you know what I'm going to show you in this lesson, so please be patient with me. I want to make sure you've got the fundamentals right before we move on to more complex topics. So in JavaScript, functions are first-class citizens, which means we can treat them just like any other variables. We can assign them to a variable, we can pass them as arguments, and return them from other functions. Let me show you. So in our starter project, I'm going to write all the code in this file, index.js. So let's declare a function called sayHello that returns a string, hello world, as always. Now, let's declare a variable called fn. We can set this to a number or a boolean or a string, but we can also set it to a function, sayHello. Note that I'm not calling this function because if we call it, we get its return value, which is a string. We don't want to call the function. We simply want to pass a reference to it. So functions are first-class citizens in JavaScript. We can treat them like any other type of objects. Nothing special about them, okay? Now, fn is an alias for sayHello. So we can call it just like calling the sayHello function. The result is exactly the same. We'll get a string back, okay? Now we can also pass a function as an argument to another function. So let's declare another function called greet, which takes a function for generating a message. Now here we can do a console.log and pass the return value of this function. So our greet function takes a function as a parameter and calls it over here, okay? Now we can call greet and pass a reference to the sayHello function. Once again, I'm not calling this function. I'm simply passing a reference to it, okay? So in JavaScript, we can assign a function to a variable. We can pass it as an argument. We can also return it from another function. So let's get rid of this code. In our sayHello function, instead of returning a string, we can return a function. In this case, an anonymous function because this function does not have a name. Now, inside this function, we're going to return hello world. With this structure, if we call say hello, we're going to get a function back. Okay, that is this anonymous function over here. Now we can call this function and get our message. Now you might be wondering, what is the purpose of this? Why do we want to return a function here instead of a regular string? Well, this is a very powerful technique and it has a lot of applications in the real world. You're going to see that soon. All I want you to understand now is that in JavaScript, functions are first-class citizens. We can treat them like any other variables. In the last lesson, you learned that in JavaScript and other functional programming languages, we can pass a function as an argument and return it. Now, in this example, these two functions, greet and say hello, these functions have a special name in functional programming. They're called higher order functions. So a higher order function is a function that takes a function as an argument or returns it, or both. So instead of working on strings, numbers, or booleans, it goes higher to operate on functions. This is the reason why we call them higher order functions. The chances are you have worked with these higher order functions before without being aware of it. Let me show you. So I'm going to declare an array of numbers, 1, 2, 3. Now we can call numbers.map. Map is an example of a higher order function because it takes a function as an argument. So here we can pass a function like this. Number goes to number times 2. So we take each number and multiply it by 2. Another example of a higher order function in JavaScript is the setTimeout function. So we can call setTimeout. Here we should pass a function as an argument. Let's say we want to do a console.log of hello after 1 second. So setTimeout is a higher order function because it takes a function as an argument. Earlier, I told you that the idea of functional programming is to write a bunch of small and reusable functions and then compose them to build more complex functions for solving real-world problems. Here's a real example. Let's say we have a variable called input and we set it to JavaScript. Now let's add some padding around this. Let's say we want to get the input, trim it, and then wrap it inside a div element. So we declare another variable. Here we add the opening element. Next, we add our trimmed input. And finally, the closing element. Not bad. It works. This is a non-functional style of code. Now let me show you how to solve this problem using functional programming techniques. So what are the 2 steps that we need to follow here? First, we need to trim the string, and then we need to wrap it inside a div element. So we can implement each step using a small reusable function. So I can declare a function called trim that takes a string and returns the trimmed string. Okay. Here I'm using const because I don't want to reassign this function. Okay. Now, similarly, we can create another function, wrap in div, that takes a string. It doesn't care if the string is trimmed or not. It only wraps the string inside a div element. So here we can add an expression like this, div plus str plus /div, or we can use a template string that is cleaner and more concise. So instead of using quotes, we use the backtick character, and here we define a template. So we add our div element. Now in the middle, we want to render the string dynamically. So we add a $sign and wrap it with braces. And with this, we can render this dynamically. Okay. So now we have 2 small and reusable functions. These functions, as you can tell, are very easy to test. All we have to do is to give them an input and then observe the result. Very simple. Now, what do we want to do here? We have this input, right? We want to trim it first. So we call the trim function and pass the input. The trim function is going to return the trim string. So we can pass that as an argument to our second function, wrap in div. There you go. So we get the result. And this is what we call function composition in functional programming. Now we could take this to the next level. We can also create another function for converting a string to lowercase. So to lowercase. Once again, this function takes a string and returns the string in lowercase. Now we can take the output of the trim function and pass it to lowercase. So this is another example of composition. Now we have a couple of tiny problems here. The first problem is that we have to read this expression from right to left. So we have an input, then we need to trim it, next we need to convert it to lowercase, and then wrap it in div. That's one problem. The other problem is all these parentheses here. As we work with more complex problems, we'll end up with so many parentheses. I'm going to show you how to solve these problems in the next lesson. In this lesson, I'm going to show you how to use Lodash to simplify the code we wrote in the last video. So in case you're not familiar with Lodash, it's basically a very popular utility library for JavaScript. It also has a package with a lot of functions for functional programming. I'm going to show you how to use them in this lesson. So back in our project, open up a terminal window and install Lodash. All right, beautiful. Now, on the top, we're going to import two functions from Lodash. One of them is compose, the other is pipe. We're going to import them from Lodash/fp, as in short for functional programming. So all these utility functions for functional programming are defined in this package. Now, with these two functions, we can get rid of all these unnecessary parentheses over here. Let me show you. So first, I'm going to use the compose function. We call compose and give it 3 arguments: wrap in div, to lowercase, and trim. Once again, note that I'm not calling any of these functions. I'm simply passing a reference to them. So compose is another example of a higher order function because it takes a bunch of functions as arguments and returns a new function that is the composition of all these functions. So it's a higher order function. Now, we can get the return value, which is a function, and store it in a constant called transform. Then we can call transform and give it the input. So with the compose function, we no longer need to do these nested function calls. Our code is cleaner. We don't have all these parentheses polluting the code. There's just one tiny problem here. That is the order of our operations. So once again, we have to read this code from right to left. To solve this problem, we can use the pipe function. So we call pipe and list our functions in the order we want to apply them. So first, we're going to trim the input. Then we're going to convert it to lowercase. And finally, we're going to wrap it in a div. So we no longer need this ugly code with all these parentheses. Delete. Good. In this lesson, I'm going to show you a powerful functional programming technique called currying. Unlike what you might think, this has nothing to do with food. This is named after this guy, Haskell Curry. So back to the problem from the last video. Let's extend this program and create a function for wrapping a string inside a span element. So over here, we create a new function, wrap in span. And let me copy this code from here and then replace div with span. Pretty straightforward. Now there's a problem in this code. We have a bit of duplication. These two expressions look very similar. The only difference they have is in the type of element. It would be nice if we could parameterize this function. So instead of wrap in span, let's call it wrap and give it 2 parameters, type and input string. Then instead of the span, we're going to render the type. Okay. Now let's get rid of wrap in div and instead use our new function, wrap. Finally, let's log the return value of the transform function on the console. Save the changes. So here's what we get. JavaScript, undefined. That doesn't make sense. Here's the reason. This pipe function essentially builds a pipeline. The output of each function ends up being the input of the next function. So what is the output of the to lowercase function? It's our input string in lowercase, right? So that gets passed to a wrap function. Now this function has 2 parameters, type and input string. So our input string in lowercase gets passed as the type argument, and the second argument becomes undefined. That is the reason why we get this result. Now, what if we call wrap and pass div as the type of element? Let's save the changes. Back in the console, we get this error, expected a function, because every argument to the pipe function has to be a function. In this case, we're calling the wrap function and give it div as the type of element. So this is going to return a string. We cannot pass a string in the pipe function because we cannot build a pipeline with a bunch of functions and a string. It doesn't make sense. So here's the problem you're facing. We have a function with 2 parameters, but what we need in this pipeline is a function with a single parameter. And that's the problem that currying solves. Let me show you. So I've created a separate file called currying. Let's study currying in isolation, and then we'll come back to our main file. So let's say we have a function for adding 2 numbers, a and b. Here we return a and b. Currying is a technique that allows us to take a function that has n arguments and convert it to a function that has a single argument. So to apply currying here, we get rid of b as the second parameter. And instead of returning this expression, we're going to return a function that takes a parameter called b. And then inside this function, we're going to return a plus b. So when we call the add function, let's say add1, this is going to return a function. Let's call it add1. So every time we call this function and give it a value, it's going to add 1 to it. Okay? Now, in this case, we don't need to store this function in this constant. We can call add1. We know that this returns a function, so we can call that function and pass our second argument. So with currying, instead of separating our arguments with comma, we separate them using parentheses. But what matters here is that we have a function with a single parameter. Now we can also rewrite this function using an arrow function. So let's declare a function called add2. Now this function should take a parameter called a and return a new function. So a goes to. Now here we should return a function that takes a parameter called b. So b goes to and returns this expression. So once again, instead of separating our parameters using a comma, like a and b goes to a plus b, we're separating them using arrows. This is the result of currying a function. Now let's apply this technique in our main program. So the problem we have here is that the wrap function takes 2 parameters. We want to apply currying here, so we end up with a function with a single parameter. So to separate these parameters, instead of a comma, we're going to use an arrow. So we don't need parentheses because we have a single parameter. Type goes to, string goes to this expression. This is our curried function. Now, here's the interesting part. When we call wrap and pass div, we get a function instead of a string. So we can pass that function as another step in our pipeline. Let's save the changes. And here's the final result. So we wrapped JavaScript in a div element. With this new implementation, we can replace div with a span or any other elements. Save the changes. There you go. So we don't have to create so many functions for creating HTML elements. Hey, Mosh here. Thank you for watching my Redux tutorial. This tutorial you've been watching is actually the first hour of my complete Redux course that is 6 hours long. So if you enjoyed this tutorial and want to learn more, I highly encourage you to take the full course because it goes way beyond this tutorial. If you enroll, you will also receive a certificate of completion that you can add to your resume. If you're interested, I'll put the link down below. Another important concept in functional programming is pure functions. We say a function is pure if every time we call it and give it the same arguments, it always returns the same result. Let's look at a few examples. Look at this function. Do you think this function is pure or not? It's not, because every time we call it, this math.random method generates a new value. So the result of this function is going to change. In contrast, this function is pure, because every time we call it and give it 1, we always get 2. So in pure functions, we cannot use random values. We cannot use the current date time because again, this will change. We cannot read or change global state like DOM elements, files, databases, and so on. Because if we rely on global state or change it, this can affect the result of our pure functions. Now you might say, but Mosh, how are we going to update our DOM elements or our database? Well, in practice, not everything has to be pure, at least when practicing functional programming with JavaScript. In Redux, we have special functions called reducers. We'll talk about them in the next section. When building Redux applications, we have to make sure that our reducers are pure. Other functions in our application can be impure. That's not the end of the world. Now, in pure functions, we cannot mutate our parameters, because if we do so, again, the result of a pure function can change. Let's look at a few more examples. So this function takes the age of someone and compares it with minimum age. As you can see, minimum age is not defined here, so it's a global variable. Now, if we rely on this global variable to see if someone is eligible or not, the result of this function can change in the future. So if somewhere else we change the minimum age from 18 to 21, this function is going to return something different. To make this function pure, we have to pass minimum age as a parameter. So everything this function needs should be specified in its parameter list. Now, what are the benefits of pure functions? Well, the first benefit is that these functions are self-documenting because everything a function needs is clearly specified here. Now, this makes these functions easier to test because we don't have to set some global state prior to testing these functions. Also, because we don't use global state or change it, we can run these functions in parallel. And finally, another benefit of these functions is that they're cacheable. For example, if we call this function and give it two arguments like 1 and 2, and we know that this always returns 3, we can store the result in a cache and use it in the future. This is useful in functions that have intensive computations. So if we know for sure that they produce the same result or the same arguments, we can optimize them by reading the result from a cache. So these are the benefits of pure functions. In the last video, I told you that pure functions cannot change or mutate their arguments. So a concept that goes hand in hand with pure functions is immutability, which basically means once we create an object, we cannot change or mutate it. If we want to change that object, we have to take a copy first and then change that copy. For example, strings in JavaScript and in most programming languages are immutable. So if you have a string and then try to convert it to uppercase, we get a new string. The original string is not affected. In contrast, if you have an object, we can change or mutate that object directly. So in JavaScript, objects and arrays are not immutable. And that's why I told you that JavaScript is not a pure functional programming language. In pure functional languages, we cannot mutate data, period. But in JavaScript, we can mutate objects and arrays because JavaScript was not designed to be a functional language. It's a multi-paradigm language, but we can still apply functional programming principles when writing JavaScript code. Now, what about the const keyword? Well, this is a common misconception. When you use const, you're not creating an immutable object. So we can declare book as a constant and then change its title property. With const, we cannot reassign book to a different object. So const prevents reassignment, okay? Now, what are the benefits of immutability? Well, the first benefit is that it makes our applications more predictable. If we call a function and pass an object to it, we know that object is not going to get changed. So there are no surprises down the road. The second benefit of immutability, which is kind of specific to React and Redux kind of applications, is that it makes it faster to detect changes. So you know that React needs to know when the state is changed so it can trigger re-rendering. For example, let's say we have a book object stored in the memory location 100. Now, if we follow immutability, to change a property of this object, we have to create a new object. This object is going to be stored in a different location in memory, let's say 200. Now, React can quickly tell if an object is modified because it compares these objects by the references. It's like comparing 100 with 200. This is a very fast operation. In contrast, if we don't use immutability, React has to compare every property of an object to see if it's changed. So immutability makes change detection faster. And the third benefit of immutability is concurrency. If we know that a function does not mutate data, we know that we can safely run this function in parallel. It's not going to change something in memory that's going to mess up the state of the system as a whole. So doesn't mean object mutation is bad and we should always favor immutability. Well, if you ask John Smith, he would say that's exactly right. But in my opinion, every approach, every technique has its own uses, pros, and cons. Anyone telling you that one technique is objectively good or bad in all situations is selling you something. So we talked about the benefits of immutability, but these benefits are not free of cost. There is a potential performance cost to immutability because every time we change an object, all the values should be copied to the new object. However, this would only be an issue if you're dealing with a large number of objects, let's say several thousand or hundreds of thousands of objects. If you're dealing with a few objects, that's not going to be an issue. Another problem with immutability is that copying objects can also cause memory overhead. But we have immutability libraries out there that reduce these overheads as much as possible. They use a technique called structural sharing. So if some values are common between two objects, they're not copied across, they're shared. We'll talk about these libraries soon. So the bottom line is, if you're building applications with Redux, you should not mutate data because that's a fundamental principle in Redux. Outside of Redux, you can do whatever you want. So now that you understand what immutability is and why it's important, let's see how we can practice it in JavaScript. So let me show you how you can practice immutability when working with objects. So here we have a person object with a name property. Now, if you want to update this object, we're not supposed to set the name property directly. We should take a copy first and then update the copy. There are basically two ways to do this in JavaScript. One way is to use the object.assign method. With this method, we can copy the content of an object to another object. So as the first argument, we pass an empty object. Then we pass our person object. So this is going to copy all the properties of this object into this empty object. Now, optionally, as a third argument, we can supply an object with updated properties. For example, if you want to change the name property, you add that here. Let's set this to Bob. We can also add additional properties. Let's say we can set age to 30. Now, this method is going to return a new object. So let's call that updated and then log it on the console. So we have this object with name set to Bob and age 30. So object.assign is one way to solve this problem, but there is a better way. We can use the spread operator. So I'm going to set updated to an empty object. Now here we want to copy all the properties of the person object. So we type ... person. This is what we call the spread operator. Now that we have copied all the properties of the person object, we can supply any additional properties. So if you want to update the name, you can pass it here. In this case, the second name property is going to overwrite the name property that we copied from the person object. Okay. Now save the changes. And here's our updated person. So I personally prefer the spread operator syntax because it's more concise. Now, one thing you need to be aware of when using the spread operator or object of assignment is that both these methods do a shallow copy. So you have to be careful when working with nested objects. For example, let's add an address property here. So address, we set it to an object with two properties, country, USA, and city, let's say San Francisco. Now, we're copying this person and changing his name. Now, let's see what happens if we type updated.address.city, we set it to New York, and then log the original person object. See what happens. So save the changes. So our original person object, his name was John. Now look at his address. It's updated to New York. Because this spread operator does a shallow copy. In this case, this address property is set to an object. The problem we have here is that both the person and updated objects have the same address. This is the same address object in memory. So if we change the address through one reference, like updated, it will apply to the other reference. To solve this problem, we have to do a deep copy. So let me show you. First, we copy all the properties of the person object. Then we add the address property. We set it to a new object because we don't want to use the same address object associated with our original person object, okay? So we set it to a new object. In this object, first we should copy all the properties of person, that address, and then if we want, we can change one of its properties. Let's say we can change the city to New York, okay? Now, we don't need this line over here. Let's save the changes. So if you log the original person, you can see its address is not modified. So when working with nested objects, we have to do a deep copy. Now, as you can see, this approach is a little bit verbose. The more nesting we have, the more verbose our code is going to be. This is why we have libraries specifically made for immutability. We're going to talk about them later in this section. In this lesson, I'm going to show you how to practice immutability when working with arrays. So here we have an array of 3 numbers. Let's look at 3 different scenarios: adding an item to this array, removing an item, and updating an existing item. So for adding, once again, we can use the object spread operator. So I'm going to declare a new constant called added and set it to a new array. Now, first we want to copy all the elements in the numbers array, and then we want to add a new element at the end. This is how we can achieve this. If you want to put this element at the beginning, we can do it like this. Very easy. What if you want to put it at a specific position? Let's say just before 2. Well, first we need to find the index of 2. So index, we set it to numbers, that index of 2. Now, we're going to create a new array. First, we have to copy all the items before 2. To do that, we use numbers, the slice. We give it a start index, that is 0. This is going to return a new array with all the elements starting from index 0 up to the element at this index, but excluding this element. Now, as I told you, the slice method returns a new array. So we have to spread that array. Otherwise, we'll end up with an array of arrays, okay? So we copy all the items before 2. Now, we add our new item, let's say 4. And then we need to copy all the items starting from 2 all the way to the end of the array. So once again, we're going to use numbers.slice. As the start index, we're going to pass index. Now, because this returns an array, we have to spread that array. Okay? Let's do a console.log. So console.log of added. And here's the result: 1, 4, 2, and 3. Now, what about removing? Well, this is very easy. Let's say we want to remove 2. So we use the filter method. Here we pass a function. So n goes to, we want to return all the elements except 2. So n not equal to 2. This returns a new array. Let's store it in this constant called removed and do a console.log. So 2 is gone. Now, what about updating? This is fairly easy as well. So we call the map method on our numbers array. Here we pass a function, n goes to. Let's say we want to replace 2 with 20. So if n equals 2, then we're going to return 20. Otherwise, we'll return n. Now, if we had an array of objects, here instead of just returning some number, we would have to copy that object. So we would have to use the spread operator to take a full copy of that object. Okay? So let's store the result in updated and then do a console.log. Take a look. So we replaced 2 with 20. Now, if you forget any of these patterns, don't worry. I'm going to include all the source code that I'm writing throughout this course in a separate project that should be available in the zip file that you downloaded at the beginning. So let me show you what I've done. Here I've created a folder called functional, and all the code that I've written throughout this section is available in this folder. For example, we have examples of currying. We have patterns for updating objects. So you can always come back to the source code if you forget something. So JavaScript does not prevent object mutations because it's not a pure functional programming language. To work around this, we have to use libraries that offer real immutable data structures. There are tons of libraries out there, but the most popular options are Immutable, Immer, and Mari. Immutable or Immutable.js is developed by Facebook and is a very popular library. It gives you a bunch of immutable data structures, such as a map or a list, but there are a number of problems with this library. I'm going to talk about them in the next video. Immer is a newer library that is developed by the creator of MobX. It's becoming very trendy, and a lot of people, including myself, love it. Unlike Immutable.js, Immer doesn't give you any immutable data structures, so it allows you to work with the plain old JavaScript objects. Now, Mari, honestly, I've never worked with it, but I've heard it's popular. At the end of the day, the library you choose is entirely up to you. These are just tools. Different people love different tools. Next, I'm going to show you how to work with Immutable.js. In this lesson, I'm going to give you a quick tour of Immutable.js. So here we have a basic JavaScript code. We have a book object with a title property. We have a function called publish. It gets a book object and set its publish property to true. Next, we call this function and then log this book on the console. Pretty straightforward. Now, when practicing functional programming, we don't want to mutate objects. So this is where we can use Immutable.js. Immutable.js provides a bunch of immutable data structures. So instead of using a plain JavaScript object, we're going to use one of the data structures provided by Immutable.js. So first, open up your terminal window and run npm install immutable. Okay, so I'm using Immutable version 4.0. Now, back to this code. On the top, we need to import the map function from the Immutable library. With this map function, we can create a map or hash map. That's like a regular JavaScript object. It's a container for key value pairs. But this map object that we get from this library is immutable. So now, instead of using this plain JavaScript object, we're going to call the map function to get a map object. Now let me temporarily comment out this code. So we create a map object and log it on the console. Take a look. So this is what we get. This is not a regular book object. It has a bunch of weird properties like size, root, owner ID, and so on. So this is the first problem with this library. If we want to log the title of a book, we cannot access the title property using the dot or bracket notation. We have to call the get method, get title. Save the changes. There you go. So the first problem with this library is that we have to learn a whole new API. Now, this API is not that complex. You can learn it pretty quickly. But in my opinion, the main problem is that it's hard to integrate this with other libraries that expect plain JavaScript objects. Every time we need to work with plain JavaScript objects, we have to call the toJS method. So this returns a plain JavaScript object. Now let's bring this code back in. So when publishing a book, we want to set its publish property to true. To do this using Immutable, we have to call the set method. So set is published to true. Now, this is not going to modify the original book object. It's going to return a new object because all these map objects are immutable, like strings in JavaScript. So here we have to return the result. We publish the book, and then we can reassign the book variable, and then we can convert it to a plain JavaScript object and log it on the console. Take a look. So here's the result. So here's Immutable.js in action. As you can see, once you start using it, it gets spread out everywhere in your code base. Everywhere you have to use these getters and setters or convert immutable data structures to plain JavaScript objects. That is why I personally prefer Immer. We're going to talk about that next. In this lesson, I'm going to give you a quick tour of Immer. As you can see on NPM trends, Immer has gained a lot of popularity and is almost as popular as Immutable.js. So this orange line represents Immutable and the blue line represents Immer. So in our terminal window, let's install Immer. All right, now we have the same code that we had in the last video. So here we are mutating this book object. We don't want to do that. Let's see how we can solve this problem using Immer. So on the top, we import the produce function from Immer. Make sure to import it from Immer. Before I was recording this video, I made a mistake and imported it from immutable. The immutable library does not have this produce function, okay? So in our publish function, we are not going to mutate the book object. Instead, we're going to call the produce function and give it two arguments. The first argument is our book object over here. This is what we call the initial state. Then we're going to pass a function that specifies our mutations. So this function is going to take a book object to differentiate. Let's call that draft book. That goes to a block of code. Now in this block, we can write mutating code. So we can write draft book dot is published equals true. However, when following this pattern, this book object is not going to get modified because this draft book is actually a proxy that records all the changes we are making to this initial book object. So this produce function is going to take a copy of this object and apply all the changes we are doing here. Now, what is beautiful about Immer is that our code looks familiar to us. So we are writing code as if we are mutating an object, but our object is not going to get mutated. This is much better than using the spread operator because you saw that the spread operator can get kind of nasty when we're dealing with nested objects. We have to do a lot of cloning. With Immer, we don't have to worry about any of this. We simply follow this pattern and write code in a familiar style. Now, this produce function is going to return the updated object, so we're going to return it from our publish function. So this publish takes a book and returns a new book. Let's call that updated. And then we can log both these objects on the console. Take a look. So here's our original book object. As you can see, it's not modified. And here's the updated book object. Now that you have learned the fundamentals of functional programming, you're ready to learn Redux. So in this section, we'll be talking about the core concepts in Redux. We'll start off by talking about the Redux architecture. Then I will show you the steps that you need to follow to build an application with Redux. You will see all these steps in action using a real project. So let's jump in and get started. Earlier, I told you that with Redux, we store our application state inside a single JavaScript object called the store. This object is the single source of truth for our application state and is accessible by all parts of the UI. For example, in an e-commerce app, our store can have properties like the list of categories, products, shopping cart, the current user, and so on. What we have in the store is entirely up to us. Redux has no opinion about it. We can use arrays, objects, numbers, booleans, essentially anything that represents the data that our application needs to function. Now, we cannot directly modify or mutate the store because Redux is built on top of functional programming principles. In the last section, I told you that in functional programming, we do not mutate state. So we cannot write code like this because our store is an immutable object. So to update it, we should create a function that takes the store as an argument and returns the updated store. So in this function, we should either use the spread operator to create a copy of the store or use one of the immutability libraries that we talked about in the last section, like immutable.js or Immer. Now, this function is called a reducer. I know, the name is a bit weird and a lot of people have complained about it, but let's not worry about it for now. All that matters is that a reducer is a function that takes the current instance of the store and returns the updated store. Now, here's a question. How does the reducer know what properties in the store it should update? Should it update the shopping cart, or the current user, or the list of products? So we need another building block called an action. An action is just a plain JavaScript object that describes what just happened. Examples are the user logged in, or logged out, or added an item to a shopping cart, and so on. These are the events that can happen in our application. So we should give this reducer an action as the second parameter. Now, based on the type of the action, the reducer will know what properties of the state to update. Now, doesn't mean that all the updates are going to happen inside a single function or a single reducer. No, this is just a simplified example. In a real app, our store can have many slices. For example, here we have 4 slices: categories, products, the shopping cart, and the current user. Each reducer will be responsible for updating a specific slice of the store. As a metaphor, think of an organization with multiple departments. Each department should have a manager that is responsible for their own department. They don't have to worry about the other departments. So these are the 3 building blocks in Redux applications. We have the store, which is a single JavaScript object that includes our application state. We have actions, which are plain JavaScript objects that represent what just happened. It would be nicer if they were called events, because in programming, an event represents what just happened. We also have 1 or more reducers, each responsible for updating a slice of the store. You can think of these reducers as event handlers or processors. I think the reason they're not called event handlers is that quite often event handlers are associated with object mutation, which is something we don't do in Redux. These reducers are pure functions, so they don't touch global state, they don't mutate their arguments, and they don't have any side effects. They just get the current store instance and return the updated one. Now, how do these building blocks work together? Well, when the user performs an action, let's say they add an item to their shopping cart, we create an action object and dispatch it. The store object has a dispatch method that takes an action. It will then forward this action to the reducer. So we do not call the reducer directly. We just work with the store. The store is in charge of calling the reducer, okay? The reducer computes the new state and returns it. Next, the store will set the state internally and then notify the UI components about the update. These UI components will then pull out the updated data and refresh themselves. You're going to see all these interactions in a few minutes. Now, you might be wondering why Redux is designed this way. Why do we need these building blocks? Why do we need to dispatch actions? Well, this dispatch is like an entry point to our store. So by dispatching actions, we're essentially sending every action through the same entry point. So we have a central place where we can control what should happen every time the user performs an action. This allows us to do some really cool things. For example, we can log every action. This is how Redux DevTools works. It shows every action that has been dispatched and how the state has changed. We can also easily implement undo and redo mechanisms. So that's the idea. Over the next few videos, I'm going to show you all these building blocks in action. All right, now we're ready to build our first Redux application. We're going to build a bug tracker app using Redux. So on the UI, we're going to have a text box for entering information about a bug we just discovered. We can add this bug to a list, then we can remove a bug, we can mark it as resolved, we can change its status to in progress, and so on. Now, in this section, we're not going to spend any time on the UI because Redux is about state management. So we want to focus on Redux. We don't want to get distracted with all the complexities of building user interfaces. We'll talk about the UI later when we talk about integrating Redux with React, okay? So now let's look at the 4 steps that you need to follow when you want to build a Redux application. First, you need to design the store. You need to decide what you want to keep in the store. Next, you need to define the actions. What are the actions that the user can perform in this application? Next, you create 1 or more reducers. These reducers take an action and return the updated state. And finally, you need to set up the store based on your reducer. Over the next few lessons, we're going to look at each of these steps in detail. Now, before we get started, we need to add Redux to our project. So in the terminal window, we type npm install Redux. I'm going to use the latest version, which is version 4.0. The chances are in the future, there is a newer version available. What I'm going to show you in this course, I have confidence that's going to work with the future versions of Redux. But to be on the safe side, I highly encourage you to use the same version I'm using here. So version 4.0. All right, Redux is installed. So next we'll talk about designing the store. The first step in building a Redux application is designing the store. We need to decide what we want to keep in the store. So for a bug tracking application like this, what kind of state do we need? We need to maintain the list of bugs. So this is the simplest structure we can come up with. We can have an array of bug objects. Every bug object can have properties like ID, description, and result, which is initially set to false. This is the simplest structure we can come up with. Now, in a more real-life application, our store would probably look like this. So instead of an array, we're going to have an object with multiple properties. So this object has a property called bugs. This is where we have our list of bugs. We can have another property called current user. This can initially be null. When the user logs in, we're going to set this to an object. So in this example, our store has two slices. One slice for the list of bugs and another slice for the current user. And that means we're going to have two different reducers. Now, in this section, we don't want to worry about all these little details. We want to focus on the simplest structure that allows us to study Redux and see all its building blocks in action. So we're going to go with this structure. Later in the course, as our application develops, we can refactor this structure and turn it into something more like this. So we have completed the first step to build a Redux application. Now, the second step is defining the actions. What are some of the actions that a user can perform in our bug tracking application? Well, they can add a bug, they can mark a bug as resolved, and delete a bug. Now, in a real-life application, we could have many other types of actions. For example, the user can change the status of a bug, they can filter the list of bugs, they can change the sort order, and so on. For now, let's just focus on these actions. Now, earlier I told you that an action is just a plain JavaScript object that describes what just happened. Here's an example. We have an object with two properties, type and description. Type is the only property that Redux expects in your action objects. So if you don't have this type property, Redux is going to complain. Now here we're using a string as the value of the type property, but you can use any other type that is serializable, which means we can store it on the disk. Why? Because Redux is built on this principle that we should be able to store the state of our application on disk and reload from it later. Strings are serializable. We could also use a number here. But the problem with numbers is that they are not descriptive. We don't want to write code and compare the type of an action with, let's say, 124. Someone else reading our code would wonder, what is 124? They are not descriptive. Also, when you look at the action history in Redux DevTools, you don't want to see a bunch of numbers. You want to see a description of what has happened. That is why we use strings. Now, here I've used uppercase letters and I've separated these words using an underscore. This is a common convention in Redux code, but you don't have to follow it if you don't want to. Redux as the library doesn't care. You can use any naming convention that you prefer. I personally prefer a different convention like bug added. So I'm using a past tense because an action represents what just happened. Now here we have another property called description. So this is the data associated with this action. When the user types something in the text box to add a bug, we store that value in the description property. In a real application, we could have a complex form with many fields. The user can specify who reported this bug, what is the severity, and so on. In that case, we will store all those extra attributes in this object. Now, earlier I told you that Redux was inspired by Flux, which is an architectural pattern and a library built by Facebook. In Flux, actions have a slightly different structure. So they have two properties, type and payload. Payload is an object that contains all the data about an action. You don't have to follow this structure in Redux because Redux doesn't care, but I personally prefer this structure because it gives my actions a common and consistent structure. Let's look at another example. Here we have an action for removing a bug, so the type is bug removed, and in the payload, we have the ID of the bug. What is important here is that the payload contains the minimum information we need about an action. So if you're removing a bug, we don't need to store the bug's description or the date it occurred and so on. All we need to identify a bug is its ID. So now that we have an idea about our actions, next we're going to build our reducer. Now we're ready to create our first reducer. So here in the source folder, let's add a new file called reducer.js. As I told you before, a reducer is a function. with two parameters, the current state and an action. The job of this reducer is to return the new state based on this action. So here's an example. If action.type equals bug added, then we want to return the new state. Now, earlier we decided to use a simple array to represent our store, an array of bugs. So if the user adds a bug, we want to return a new array. In this array, first we want to copy all the bugs in the current state. So here we're using the spread operator. And then we add a new bug object here. This object should have a few properties like ID, description, and result. So we set description to action, that payload, that description. And we set resolved to false. Now for the ID, we need to have some kind of counter. So I'm going to declare a variable here, last ID, and initialize it to 0. Now, every time we add a bug, we're going to increment last ID first and then use it as the value of the ID property. Now, there is something I want you to pay attention to here. The payload of the action should contain the minimum information we need to update our system. So in the case of adding a bug, we don't want to pass the ID or result properties because the minimum information we need for adding a bug is the description of the bug. So everything else should be computed here in the reducer because this is where we implement our business logic, okay? Also, here I'm using the spread operator to copy this array. We don't have to do this. We can use one of the immutability libraries like immutable.js or immer. We'll use them later in the course. For now, I just want to show you the plain Redux code because that's what you see in most projects. So here's a case for adding a bug. So after our return statement, we can have else if action, the type equals bug removed. Now here we want to return a new array that contains all the bugs except the bug with the given ID. So I showed you how to do this in the last section. We basically get the existing array and filter it. So here we pass a function. We get a bug. We want to return all bugs except the bug with the given ID. We can pick that from action, that payload, that ID. Simple as that. Now, what if the type of our action is neither of these? We should return the current state. This is very important because if we make a mistake, if we dispatch an action that doesn't exist, we don't want our system to blow up. We want to return the current state, okay? We're almost done. The only part that is missing is the initial state. So when we start our application, the store is initially undefined. Redux is going to call our reducer and pass undefined as the value of the state. In that case, we want to return the initial state. We don't want to return undefined or null. Now, what is the initial state here? That is an empty array. So we can set that using a default argument over here. So when we start our application, Redux is going to call our reducer and pass undefined as the value of the state. In that case, we're going to reset the state to an empty array, okay? Now, in this example, I'm using an if and else to implement this logic. We could also use a switch and case statement. Redux doesn't care. It's entirely up to you. Some people don't like switch and case. If you prefer if and else, go for it. But let me show you how to implement this logic using a switch and case. So we switch on action, the type. Here we're going to have two cases. One for bug added and another for bug removed. Now for each case, I'm going to copy the code from here. So here's our return statement, cut. I'm going to add it here. And finally, for bug removed, we have another return statement. Very easy. We also need a default case if the action type is none of these values. In that case, we want to return the current state. So here's our final implementation. Now, one thing I need to emphasize here is that this reducer is a pure function. We talked about pure functions in the last section. A pure function is a function that if we call it multiple times and give it the same arguments, it always returns the same result and is free of side effects. So in a pure function, we're not going to touch DOM elements. We're not going to work with any global state. We're not going to make API calls because all these operations can change the state of our system as a whole. In that case, if we call this pure function multiple times, we may not get the same result. So a pure function should be a small function in an isolated world. All it needs should be passed as arguments. These are the only dependencies of a pure function. So this reducer, this pure function, takes these two arguments and returns the new state. That's all it does. Now, these properties make it really easy to test this reducer. We don't have to set some global state before calling this function for testing. So in Redux, reducers have to be pure. Now, you might be wondering how we're going to make API calls. We'll talk about that later in the course. For now, don't worry about that. Now that we have a reducer, we are ready to create our store based on this reducer. So in the source folder, let's add a new file, store.js. Now here first we should import the create store function from Redux. Next we call it. Now here we should pass our reducer. So that means we should go to our reducer file and export this function. I would prefer to export it as a default object so we can easily import it in other modules. So save the changes. Now we can import reducer from the current folder, reducer module. Now if we didn't do a default export, we would have to wrap this in braces. With a default export, we don't have to do that. So this is the only object that is exported from this module, okay? So we pass our reducer as an argument, and note that I'm not calling it, I'm just passing a function reference. So create store is another example of a higher order function because it takes a function as an argument, right? Now this returns a store object. So finally we need to export it so we can bring it in our main application. We'll do that next. So we created the store, now let's use it. So in index.js, first we should import the store from the store module in the current folder. Note that I'm not wrapping this in braces because I exported the store as a default object, okay? So here's our store. Now, before going any further, let's just log this on the console and see what it really looks like. So save. Now, there you go. So a store is an object with these properties. We have a method for dispatching actions. We have a method for subscribing to the store. So when we subscribe to the store, we get notified every time the state of the store changes. This is used by the UI layer. You're going to see that very soon. We also have a method for getting the current state of the store. We also have replace reducer and symbol of observable. These are advanced topics. We'll talk about them in the future. Now, what is interesting here is that we do not have a method for setting the state of the store. We only have get state, not set state. This is a fundamental principle in Redux. So to change the state of the store, we have to dispatch an action. With this architecture, we're essentially sending every action through the same entry point. That is the beauty of Redux. So back to our code, let's call getState and look at the current state of the store. So save. So initially we have an empty array because we haven't added any bugs yet. So let's dispatch an action. So before console.log, we're going to call store.dispatch and pass an action. This action should have two properties, right? One is type, which we set to bug added. The other is payload, which is an object with a property called description. And we can set this to bug1. So in a real application, when the user clicks on the add button, we're going to dispatch an action. Now, save the changes. There you go. So in this array, we have a bug object with ID set to 1. Here's the description, and it's not resolved. Now let's dispatch an action for removing this bug. So right after, we're going to dispatch another action. The type of this action is going to be bug removed. And in the payload, we just want to pass the ID of this action. We don't need anything else. So save the changes. Now our store is back to its initial state. All right, now let's see how we can subscribe to the store. So before dispatching an action, I'm going to call the subscribe method. Here we should pass a function. This function gets called every time the state of the store gets changed. So here we can log store changed. And as the second argument, we can get the current state of the store. So store.getState. This is basically something we do in the UI layer. So whenever the state of the store changes, we want to refresh the UI. If you're building an application with vanilla JavaScript or jQuery, this is where we're going to work with our DOM elements. We're going to refresh the view. If you're building an application with React, we're going to re-render. Now, we'll talk about that in the future. For now, what you need to understand is that UI components should subscribe to the store so they get notified when the state of the store changes. Okay, so let's save the changes back in the browser. So you can see our store changed twice. This is the first time. So we got a new bug, and then we remove that bug. Now, this subscribe method returns a function for unsubscribing from the store. So let's store that over here, unsubscribe. This is important because it is possible that the user navigates away from the current page, and in the new page, we're not going to have that UI component. So we don't want to have a subscription to the store because these subscriptions can create memory leaks. So if the current UI component is not going to be visible, we should unsubscribe from the store. Let me simulate this. So let's say we added a bug. Now I'm going to call unsubscribe. So the second time we are dispatching an action, we are not going to get notified. Save the changes and take a look. We only have one message that indicates that the store is changed. The second time the store got changed, we did not get notified because we had unsubscribed before. You have seen all the building blocks of Redux: actions, reducers, and the store. Let me walk you through the Redux workflow one more time. So when we dispatch an action, our store is going to call our reducer. It's going to give it the current state and the action that we dispatched. Based on the type of the action, we're going to get the new state. So this dispatch method, if you look at its source code, it actually looks like this. It calls the reducer, gives it the current state and the action that we dispatched, and then it will get the new state, which is going to store here. So this is the internal state of the store. Okay. Then it's going to notify the subscribers. Now, in the next section, I'm going to show you how to build Redux from scratch. So you're going to code all of this. But before we get there, I need to emphasize that Redux is actually a very small and simple library. It has a small API. It has a small footprint. Earlier, you saw that the store object has only a few methods that you have to learn about: get state, dispatch, and subscribe. So there are very few moving parts in Redux. However, when building real-world applications with Redux, we often introduce additional building blocks that make our code more maintainable. For example, one problem we have in this implementation is that we have hard-coded this string in two places. One is here, where we are dispatching an action. The other is in our reducer, where we are handling this action. What if tomorrow we decide to rename this from bug added to bug created? Then there are multiple places in our application that we have to update. And if we don't do so, we're going to create a bug. So let me show you how to fix this problem. We're going to add a new file called action types. We're going to store that string in a single place and use it in multiple places. So here we're going to export a constant called bug added and set it to that string, that magic string. Similarly, we can create another constant called bug removed. This is the only place where we're using this string literal. If tomorrow we want to change it, this is the only place we have to update. Now, we go to our reducer and replace the string with the constant that we just exported. So on the top, we're going to import. We can use a named import, so we can import bug added and bug removed. from the action types module. That's one way. The other way is if we're dealing with multiple action types, we don't want to pollute this import statement, so we can import everything as actions. Now, this actions is going to be an object with properties like bug added and bug removed. Let me show you. So we're going to replace bug added with actions dot look. We have these two properties, bug added. Similarly, we're going to replace bug removed with actions dot bug remove. Well, actually, I should have used bug removed. So let's rename this to bug removed. Okay, good. Now, finally, in our index.js, when dispatching an action, we're going to use that constant one more time. So let's import everything as actions from action types. And then we're going to set the type to actions dot bug added. As simple as that. The other problem we have in this implementation is how we dispatch an action. As you can see, dispatching an action is not easy. We have to type the entire structure of this object. Now, what if there are multiple places where we want to dispatch the same action? Then we have to repeat all this structure in multiple places. To improve this, we can create a function that would create this action object for us. We call that an action creator. So in our project, in the source folder, let's add a new file. We can call it actions or action creators. I prefer actions, but that's entirely up to you. So here you want to create a function called bug added, which takes a description and then returns this object structure over here. So let's cut that and then paste it here. Pretty simple, right? Now we can export this and import it in our main module. So in this case, we don't need this import statement anymore because we need action types only when creating an action. So I cut that line and paste it here. Okay, this is where we're using our constant. Now, in the index module, I'm going to import bug added from the actions module. So here we have a named export because bug added is not a default export. Okay. Now, when dispatching an action, we simply call this function bug added and give it the description. This makes our code a lot cleaner. And if you want to dispatch the same action from multiple places, we simply have to call this function. We don't have to worry about the structure of this action object. If tomorrow we want to change the structure of this action, there is a single place that we have to update. Okay? So this is why we use action creators. Now, I personally prefer to create my action creators using an arrow function because they have a more concise syntax. Let me show you. So let me comment this out. Now, we're going to export a constant called bug added and set it to an arrow function. This function should take description as a parameter and return an object. So here we cannot use curly braces because these braces indicate a block of code. But here we want to return an object. So we should wrap this in parentheses. Now, this is the action object that we want to return. So it should have these two properties, type and payload. I copy these, paste them here, and then remove the comment. So this is another way to create an action creator. Now, what syntax you use is entirely up to you. Here's an exercise for you. I want you to implement resolving a bug. So we should be able to create a bug and then mark it as resolved. Spend 5 to 10 minutes on this exercise and then come back see my solution. To implement a new feature with Redux, you should always think about your actions first and then your reducer. So we want to define a new action or a new capability or a new event that can happen in our application. That is resolving a bug. So first we go to our action types module and define a new constant called bug resolved. Once again, I'm using the past tense here to represent an event that just happened. So we set it to bug resolved. Next, we should create an action creator. So in the actions module, we export a new constant called bug resolved and set it to a function. Now, what pieces of information do we need for resolving a bug? At a minimum, we need to know the ID of the bug. So ID is going to be a parameter, and here we want to return an object. So we wrap that object in parentheses. Now, the type of this object is going to be actions.bugResolved. Note that the benefit of importing the actions using this syntax is that every time we define a new action, every time we define a new constant, we can simply use it in this module. In contrast, if we used named imports, let's say bug added from action types, every time we define a new action type, we have to come back and add that new action type here. So this is a simple tip. We import everything as one object. Now, we set the type and then the payload. Here we can simply add the ID of this action. Now, in modern JavaScript, if the name of a property and the value are the same, we can use a shorthand syntax, so we get rid of it. And by the way, I noticed that in the last video, I made a mistake. I hard-coded bug1 here, but we should set the description property to the description argument. So we set it to description, or we use the shorthand syntax. All right, we're done with our action. Now we should change our reducer so it can handle our new action. So let's go to reducer.js. Here we want to add a new case. Case actions.bugResolved. See, that's another benefit of importing all the actions as a single object. I didn't have to go on top of the file and import our new action. Okay. So when a bug is resolved, we want to update an existing bug object. I talked about this pattern in the last section. So basically, we want to use state.map. Here we pass a function. It takes a bug. Now, if the ID of this bug does not equal action.payload.id, if this condition is true, we want to return this bug as is. Otherwise, we want to take a copy of this bug and modify it. This is updating in an immutable way. So here we want to return a new object. First, we want to copy all the properties of the bug, and then we want to set the result property to true. Okay, let me put this on a new line so you can see clarity. So using the map method, we're mapping this array to a new array. If the ID of the bug is not equal to the ID of the bug that we have resolved, we're going to return that bug. Otherwise, we're going to return a new bug object with all the properties of the existing bug, but with the updated resolved property. As you can see, writing code like this is a little bit confusing and complex. That is why we should use libraries like Immutable.js or Immer. This is one of the main reasons that a lot of people find Redux confusing. But don't worry, later in the course, I'm going to show you the modern way of writing Redux code that is very clean and concise. For now, I want to use the traditional way because that's what you see in most projects. So our reducer is now capable of handling this new action or this new event. With that, we can go to our index module. And after creating a bug, we want to resolve it. So store.dispatch. We should import our new action creator, bug resolved. Then we call it over here, bug resolved, give it the ID, and we're done. Save the changes. So take a look. In this array, we have one bug that is resolved. Beautiful. Hey, Mosh here. Thank you for watching my Redux tutorial. As I told you before, this tutorial is the first hour of my complete Redux course that is 6 hours long and covers a lot more. So if you want to learn more, I highly encourage you to enroll in my complete Redux course. You'll also receive a certificate of completion that you can add to your resume. If you're interested, I'll put the link down below. Thank you for watching, and I hope to see you again. Please support me by liking this video and sharing it with others. And be sure to subscribe for more videos like this.